So for our next session, we have Dmitry over here with us. He's a technical evangelist at Microsoft, a senior technical evangelist at Microsoft. He's also an associate professor of Moscow Institute of Physics and Technology. This is impressive. Yeah, he works a lot with AI, functional and logical programming, and he's here to give us a bit of a glimpse on AI and machine learning on the .NET platform. See that you can do this, and you can leverage your existing skills to tinker around in this universe. So, Dmitry, you have the stage.
Thank you. So first of all, let me start by saying that I'm very glad to be here, actually for two reasons. First of all, I was planning to be here last year, but for some reason I couldn't get the visa in time. And actually now that I'm here, it's really surprising to see such a full room of people interested in .NET. I know that there is a Java conference going on in parallel, and it doesn't really affect, still there is a full room of .NET lovers. That's really great. And actually, about myself, I was a technical evangelist at Microsoft for like almost 10 years. I was in love with .NET. I gave talks about .NET. And then I had to switch a little bit and go into AI and ML. And for the last year, I mostly program in Python. And that's actually a pain. I managed to make this pain a little bit smaller by developing my own library, which makes Python look almost like F#. But the reason I want to talk here today is that I want to show different opportunities to use AI and machine learning on .NET platform. So as you already know, I also teach. I'm also interested in how to teach kids to do programming and lately AI and ML. So if you have anything to talk on this matter, I would gladly talk after the presentation about that. And let me start a little bit further by saying why AI is important all in all. My favorite example of AI used today is McDonald's. You would actually have the whole talk in the agenda today about digital transformation. And for me, the good example of digital transformation is McDonald's. McDonald's initially, like something like 10, 15 years ago, realized that it's too expensive to put people inside McAuto. You know, McAuto, when you arrive by car, you order something and then they prepare it for you. It's too expensive to put an American inside this booth. It's much easier to do like remote call center in India, so that somebody would talk to you and take the order, and that would be it. This case is described in the book called The World is Flat. It was a popular book like 10 years ago about the start of digitalization, about the start of digital transformation. And the fact that you can actually digitize your voice and send it over somewhere made it possible to outsource this somewhere to India, for example, and everybody was happy. Like McDonald's saved costs. Hopefully, it allowed them to make the hamburgers better, and people in India got their job. Now, something like maybe 1.5 years ago, McDonald's had a project together with Microsoft on getting rid of people in this chain, so that the computer would automatically recognize the voice. And it was quite successful because, you know, it's not rocket science, and people would not talk with a computer about the meaning of life. In McDonald's, they would just do the order, and order, you typically know all the ingredients. And so in this task, computer became actually better than human, because sitting in the booth in McDonald's with a noisy environment, it's a very difficult job to take the order. And there was a paper in 2016 done by Microsoft Research which said that they achieved human parity in speech recognition, meaning that computer recognizes voice almost as good as human being. In 2015, the similar case was done in relation to image recognition. So there was a paper saying that if we give 1,000 images like of road signs to people and to computer, both of them make something like 8% error, because the image is small, because people get tired and computers don't. So now we live in the world where computers can do some things better than human. Doesn't actually mean that computer can see better than human. Humans has very sophisticated, very complex eyes. They can focus on different parts of the image, but in the simple task of recognizing road signs, computers are better because they don't get tired. So that brings us to the topic of artificial intelligence. Artificial intelligence is about computers replacing humans in almost every aspect of our life. And that's why it's the main driver of digital transformation. If computers replace us, we would be very happy. We don't have to work. We can just, I don't know, enjoy ourselves or go and die, whatever. To show you that the AI is actually in many places today, I will just show you the AI in PowerPoint in case you haven't seen it. It's very useful when preparing presentations. First of all, if I, for example, insert here a picture, let's say to make the presentation better, I would put a picture of a kitten in the slide. This one looks good. So if I insert a picture in PowerPoint, regardless of whether it's online or not, you see it automatically generates the caption. It says a cat with its mouth open, in case you don't see. This is done automatically based on the picture. It doesn't take it from the internet. It's if you insert any picture, it would do like that. And second thing is this beautiful thing called design ideas. You know, you can just click and it would give you the good design of the slide. I mean, this one is probably quite good. Without you need to, you know, do anything. I actually use this quite a lot nowadays, preparing presentations. And AI is in many other products, like for example, you know that there is Skype Translator, which translates from language to language, and it's in many cases. So what's important to realize about AI? In AI, algorithms, they are more or less well known. So before the competition between companies, it was based on algorithms. You know, when Google and Microsoft were competing on the search accuracy, there was like a period when they said, okay, we achieved 99% accuracy, and then Microsoft was better at some point, and then it was worse again. It was based on algorithms. In AI, everything is based on data. So the better data you have, the better result you can achieve. And that's why data becomes the new gold. It's an important asset, and the companies probably would not want to give the data away for free. And that's the reason why everybody is collecting data, you know, like Google especially. What is also important is that AI is applied in for such problems for which algorithms do not exist. It's not clear how to describe what's on the picture. I mean, it's completely not clear how, looking at the pixels, you can derive the textual description. And you don't have to know. I mean, you make the computer learn it by looking at the data. And this brings us to the topic that AI, originally, it's a very broad field. There are some, like, computers playing chess, which is AI. There are some expert systems, which is AI. But what we would be talking today about, and what is mostly developed nowadays inside AI, is the field called machine learning. And machine learning is exactly when computer learns from the data. When you have data, and the computer can, based on data, come up with the algorithm for dealing with this data. And that's why there are people called data scientists, which somehow is a different type of software engineer. Software engineer does, like, he thinks a lot, and data scientist thinks, but in a different way. He thinks about what to do with data to make it better for the computer to learn. And he has to know, you know, a lot of things. So data scientists, they are different from us because they use Python. Right? Some of them, they also use strange language called R. So for some reason, I don't know why, but it's an old language, and some people were taught in the university, like they were taught R, and that's probably the reason they continue to use R. And why Python is used in data science? What do you think? I mean, for me, it was really strange. Python is terrible language, untyped, horrible. No autocomplete, like no reliable autocomplete. Because we in .NET, we used to write, I don't know about you, I mean, I wrote code like you type dot, 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 and the computer tells you what you need to type next. You don't really have to think about that. In Python, you don't achieve this goodness, you know, you have to think. This is too bad after using .NET for 10 years. So the reason why Python is popular for data science, it's not because Python is a good language. It's because the people developed originally a very good libraries for it, especially like NumPy, which allows you to, like, do things with matrices in a very easy way. Like NumPy itself is not written in Python, it's written in C++, and that's why it's fast, that's why it's usable, and the Python is used as a glue between those good libraries, and also TensorFlow. Like when it comes to neural networks, you need really complex, like GPU-based computations. All of that is, of course, also written in C++, but Python looks as a very good thing that puts those things together. And .NET is not. So that's why they use Python. For R, it's a different story. For R, somehow they have already developed a lot of algorithms in R. There is a repository where you can get them, and people don't really write much. They also use it as a descriptive language. So the question for me was initially, I mean, how can I do something on .NET platform instead of learning Python? And there are a lot of people who think in this way, because in .NET platform there is, for example, a beautiful functional language called F#. Do you know about F#? I hope you do, yeah. A beautiful functional language, and it would probably be very good for data science, because it's typed, but the code looks as it is untyped. It's very brief with type inference, and even there are some libraries developed for F# for machine learning, but that's either too late. But so it's not the case. We are not seeing .NET used a lot. So let's see different opportunities how we can use .NET for AI. If you look for official position of Microsoft, like in Microsoft, there is this beautiful slide called Microsoft AI Platform, which basically says, okay, if you want to do AI on Microsoft, you have Azure infrastructure, take our cloud and put your Python like for work there in our cloud. If you want to use something easy with .NET, you can use things called cognitive services, and there is a thing called Azure Machine Learning, which is for very complex models. It's also .NET-based thing, but Python binding is available. Please take Python and use it. That's what Microsoft documentation says. That's true. That's how things work. I mean, for the last year, I worked a lot on the customer projects. We did real machine learning models, and we did them all in Python and in Microsoft Cloud. So I'm not saying it's bad, but let's see what can be done on .NET platform. So today, I will talk about mainly three things. I will talk about some simple things, like cognitive services, pre-built models which you can use in your own projects. I will talk a little bit about ML basics and how you can build ML model from hand, from nothing, from scratch, and about ML.NET and some other frameworks. So if I'm saying something boring, please start, making some noise and throwing papers at me and making like, we don't want to hear that. Can we try that once? How would you do that? I have to hear, because I have a lot to say, but I try, as always, in a good talk, there is something which is like everybody understands and something which nobody understands. So I will start with simple things. I will start with cognitive services. Cognitive services, as I mentioned, data is very important. So big companies, they try to not give data away. What they do, they actually pre-train models on their data and sell the models. That is what's called cognitive services. So cognitive services is basically APIs which solve very typical tasks already. Like if you want to have this description of a picture, in your project, you can just call a function in the cloud, and it will return you this description. You don't have to do anything, very simple. And cognitive services, they can do quite a lot of things. They can work with pictures, they can work with speech, translation, text-to-speech, speech-to-text, understanding of different phrases. They can work with language, like with text, and some other things. There are some even very kind of experimental things called cognitive services labs, which have gesture recognitions and other things. So let me just show some examples. Like, for example, Vision API, what the Vision API can do. If you give it the photograph, as I mentioned, it can give you a description. It can also give you some tags. And this is already a very useful thing. We had a project with one media company which wanted to process their archive or file archive. They had lots and lots of pictures. I mean, they're photographers. Whenever they go for an event, they take pictures. Then some of them they publish, and the rest just sits on the hard drive, and no one looks at them because there are too many. And at some point, they might want like a photograph of a certain celebrity or certain event or like certain looking picture, and there is no way to find out there is what. And for them, like this is the perfect thing. They can just index everything with with this Vision API, and you get the keywords for everything present in the pictures. As far as description is concerned, I mean, this is used. There is an application called Seeing AI, which Microsoft developed probably for PR reasons. It's an application which allows blind people to see. They take a picture and it tells them what's on the picture. Very simple. You can put it together like in half an hour. There was also a popular thing called How Old .NET, I think, a few years ago, which tells you the age from the photograph. And I made a bot out of it. Actually, when I give longer talks, I show how to make a bot in 10 minutes, which will tell you the age. So I will just show you how it works. It's a bot in Telegram. So what I need to do, I need to take a picture. Please make sure you smile. And let's have a look. But let me tell you first that do not expect very good results, because when it sees very small faces, it can get very confused. And it doesn't find everyone. I mean, it's more than 10 people in the room probably. But it sees those who are close. And you see the main emotion is happiness, which is very nice always. You know, when I take a picture at the event and see that everybody is happy, it makes me confident that I am telling the right things. So you can actually try it yourself. It's called Oh My Mirror bot in Telegram, and you've just seen it works. And it's very simple. You just call one service and that's it. And I'll actually show you how it works on a slightly different example. I will show you a thing called Azure Notebook. Have you seen a thing called Azure Notebook? It's a very convenient way. Actually, whenever data scientists they do something, they do it in Python notebooks. It's a web-based interface. So it looks like this. And you can mix code and text. You can describe what is happening. And you can execute this code and immediately see the results. Very convenient way to do things. And Microsoft, but normally, if you're a data scientist, you will install it on your own computer, but the interface would be web-based. So naturally, Microsoft did it as a separate service. It's in public preview, so it's free for the last 2 years. I think it was free, and it was in a preview. There's also a thing called Google Colab, which does the same thing, but with Google services. So I will show you an example in F#, how to find, for example, the happiest picture of somebody, happiest picture of Stephen Ballmer. That's what my example is about. So for this, for using cognitive services, what you need a special key, which you get either in the cloud subscription, or you can get the demo version on the site. If you go to microsoft.com/cognitive, it says try computer vision, for example, for free. You click there, and you get the key for certain time. Like. So what I do here, I use the notebook with F#, because F# is the very beautiful language, as I mentioned. So what we do here, let's start with a simple way of calling the service and getting the emotions. So this is the picture which I take from the internet. And to call the service, we only need this small line of code. Because it's a REST service, what you need, you just do the REST call, and you get the JSON back. And to process JSON into something readable, I use F# data, which is basically I use Newton's of JSON, which deserializes it into the structures. So when I call the service on the picture which you have seen, he's probably a bit happy. So we see that happiness is 1, all other emotions are 0, which looks more or less correct. In addition to emotions, of course, it can give you age. If I say, for example, that I want to get the age, I would also need to describe all the structures for age. So I will not do that at the moment. But you just provide the key. Here I say that I want to detect emotion here, but I can also detect many different things. And now, just another example, I take more difficult picture. This was the lady here, which will be shown again in a second. I mean, this is not really clear what it is. And if you look at it, it says that it's a mixture of sadness and contempt and disgust and a bit of anger. For a long time, I was looking for such a picture, you know. And now the most interesting thing, I use the Bing API. So it's also Bing API is one call which returns you the sequence of pictures for a given keyword. So here is the like first 5 photographs of Steve Ballmer. You know who Steve Ballmer is? Yeah, he's the guy who shouted developers, developers, developers. And that's why it's interesting to look at his pictures and not anybody else, because he has different emotions on his face normally, like this one, and you know, hard to say what it is. So what I do now, I call this Face API on first 10 pictures. I could do more, but Face API, especially if you have a free version, only gives you a certain number of calls per second. So that's why I do a kind of pause between each call, not to overwhelm the service. And that's why it takes like 20 seconds processing 10 pictures. But you can leave it overnight and see the result. And now I can just do, you know, select the most angry picture of Steve Ballmer, and that's the most angry picture. If I want the most happy picture, I just say, I want to maximize happiness. What? No, I typed it wrong. So this is the happiest picture. What else? Disgust. Also this one. So it's an interesting, you know, you can spend time looking at different emotions like this. And if you want actually to do that, Azure Notebooks allow you to clone existing notebooks. So I'm providing the link here. You can just take this link. It would tell you, do you want to clone it? You clone it, and you get your own copy of the notebook, which you can use. But the only thing I ask, please don't use this key. That's why I probably will just delete it from here and save it before anyone could clone it, right? Hopefully. Okay, so there are many other services. I just showed you the example how easy it is to use them. And now we are moving to machine learning. So machine learning, in the traditional machine learning, you provide data. Computer magically processes the data, finds the algorithm, and comes up with a model which solves the problem. For example, if I want to determine happiness of a person on the picture, I need a lot of pictures with the faces and showing whether they are happy, sad, or something else. And then before applying machine learning, I need somehow to convert the data into the format suitable for computer to understand. So I need, actually, for machine learning algorithm, I need basically a table as an input, right? And picture is not exactly like a table. So in neural networks, you can actually take the whole picture and it would automatically extract important features from it. But in traditional machine learning, I first need to extract features. For example, from the text, from the face, I can extract the key points. And there are, like Face API can do that. It has something like 32 key points on the face. So I can extract them. I can come up, for example, with a matrix of distances between them. That would be a very good input feature for a machine learning algorithm. And then I train the model on the existing data set. Whenever I want to see whether another person is happy or not, I take the picture. This is my daughter, by the way. I extract the key points, and I give it as an input to the model. The model gives the result. Like she is 80% happy. Looks like more than 80, but yeah. So that's how machine learning works. And another example of cognitive services which uses machine learning is called custom vision. So there are really many cases where you need to detect certain objects in the picture or in the video. And traditionally, it was a very complex task. Like 10 years ago, you would write a PhD on that. Maybe not 10, maybe 12. But nowadays, Microsoft provides a service which allows you to train the service by providing a few images, and it will somehow learn to recognize them. It would not produce a very good quality model, because you cannot expect a good quality model from very generic service. But it would do quite good. Let me show you an example. It's called customvision.ai. So you basically just go to the site customvision.ai and tell it that I want a new project. I would say the demo project. it tells you what kind of task it is. Classification is basically just recognize an image, and detection is find an object in the image. That's a more difficult thing. And then it starts with a certain specific domain. So for example, what it does, it has to extract features from images. And those features, they are different in different images. For example, if you are talking about food, the textures and the edges, everything looks different from landscapes. So it's much better if you know the domain of the pictures. So what I want to show you how to build the model is recognizing the arcs. You know, this beautiful arc. When I arrived to Bucharest, this is the first thing I saw going from the airport to the hotel. Because there is the same arc in Moscow and the same one in Paris and probably in other cities as well, it's a good thing to recognize from the picture what's the city you are in if you just photograph this thing. So I would start with landmarks. I would say create project. And then I just need to upload pictures. So I say add images. I take all pictures of this arc in Bucharest. And I say it's Bucharest. Then I take all pictures from Moscow. And yeah, one more to go, Paris. Actually, the one in Paris is very similar to the one in Bucharest. When I was trying this yesterday, I tried this yesterday, so it works, I can tell you. I was a little bit afraid it would not recognize between those two because they are very similar. So you uploaded the images. Did I say Paris? I forgot to say Paris. So what I need to do now? I need to I can say select all and then tag and say Paris. Good. So now what I need to do, I say train model, and it trains the model. And while it trains the model, let me find the picture of an arc. Let's say Bucharest. Okay. So I will take one further below so that it's not being trained on it. Here it says the accuracy is 100%, which is kind of nice indication that it might work. So I can do quick test from here. I enter URL. And it tells me Bucharest 99.9%. Isn't it good? So I end up with a model which I can call using the same REST API. So it's just one call, and you recognize the images that you want. You can also, what you can also do here, you can train the simpler model, which gives you less accuracy, but it would be exportable to a local file, which you can run on mobile device, for example. You can export it to a format called Onyx, which is the format Microsoft supports for exchanging between different neural networks. You can export it to Core ML for Android and for iOS. So it's actually a very easy way to produce the model which would do like image detection, object detection for you. Now coming to more difficult things. Let's see how machine learning actually works behind the scenes. And I will start with I'll actually use as the main example a classical machine learning problem called digit recognition on the MNIST data set. MNIST is the American Institute of Standards, and at some point, like many years ago, they collected the huge data set. Well, not huge, it's like 60,000 images of handwritten digits. And because it's really good data set, I mean, all digits, they are more or less centered, and it's a kind of benchmark for machine learning. It's very easy to build a good model. But it's also a real-world task. You can imagine that if you have the task of recognizing, like on the letters, people typically write the zip code. That can be done using this dataset. So this dataset is available as the CSV file containing the flat 28 by 28 pixel images of the digits. So that's the way the file looks. CSV file. So the first is the actual digit. The field is called label, and then pixel 0, pixel 1, and so on till it comes to pixel 783. And here are the digits. So I have the how are we going to recognize them? The easiest machine learning algorithm for this is called nearest neighbor. KNN, K nearest neighbors algorithm, and it's very simple. We basically given a digit. So here on the left are our training data, 0 and 1, and on the right 1 is the input digit. And how do we find which one this one looks more similar to? We just calculate the distance between all images in the training set, and the distance we can calculate easily by just subtracting the pixels from each other, right? So for example, with 0, there are a lot of different pixels, and we get the large distance. With 1, there is just one different pixel, so the distance is smaller. So to do that, I have also the sample in F# notebook, but probably you are tired of F#. That's why I will show you how to do it in C#, and I will show you a nice feature of Visual Studio which you might not know, called C# Interactive. Because I did not know initially that you can execute C# line by line like an interpreter, like in REPL. So how do I build this algorithm? First of all, I define the simple class for digit, which would contain image and the label. So image is the array of pixels, and label is the actual digits from 0 to 9. Then I load it from CSV file. So I choose to load it by hand. I just open the file, skip the row with headers, then split them with comma, and then select the digits, converting everything to int, by the way. This shows the beauty of LINQ. So in case you didn't know, you can use LINQ for very complicated data processing. Here it is. Like, not very complicated, but still not very easy. Then I take for simplicity, I take 10,000 training images and 1,000 test images, just not to waste your time, because the more data you have, the longer everything takes to train. And then you can have a look how the digit looks like. Just let me execute that. And you see this is the digit 0. Can you see it? You cannot. Actually, it's here. If you cannot, you have to believe me that it's 0. Or maybe I can do something like this, and here it is. Then what do we do next? Next, let me define the function which calculates the distance between two arrays. Right? It's quite simple. Do you sometimes write the function in C# like this? I think it looks quite nice. It's look a little bit like F# way. So I take as an input two arrays, A and B. Then a.zip_b gives me the array of pairs. Then for each pair, I compute the square of the distance, and I add it with sum. So this is the squared distance between two digits. And then to actually classify the image, I take in the image as an input, and I find in the trained data set, I find the element which has the minimal distance between itself and the image, and I take the label. So that's the two lines of code which contain this whole machine learning algorithm. And then I can just see how it works on the test data set. I take 20 images, not to wait for a long time. I just click, it starts working. Here you see that it recognizes 90% of... yeah, can we change the view to the small one? Good. here you cannot see, but for the different reason, yeah? So it shows that which digit is recognized by like what's the recognition result, and it says 18% correct, so 90% correct images. This was quite simple, right? I mean, the 2 lines, if you compute it over the big data set, it gives you like 94.3% accuracy. Just have to wait for 3 minutes or something like this. So it was nice, 2 lines of code, and you get the machine learning algorithm working. The only drawback of this machine learning algorithm is that each time to recognize a digit, it has to go through all training set. It does not actually learn before. It learns at the moment of evaluation. So it takes a lot of time to do the evaluation. So probably we want to try different machine learning algorithms in real life to see how they work. And to do that, we don't want to write all of them by hand. We use some kind of framework. And the good framework in .NET world is not yet ML.NET. ML.NET will evolve and become brilliant and excellent, but at the moment there is a thing called the core.NET. A core.NET is simpler to use. It contains a lot of machine learning things, like it contains image processing algorithms, you can do edge detection, you can do different image filters. So beautiful, beautiful framework, for some reason not very widely known. So the way we do it in a core.NET, let me show you from scratch how to build this thing. So first of all, we also define the digit class. It's basically the same as before. I will now write it as a console application. Is it a little bit visible? Okay. So the digit class. Then what I do, I load the data. It's pretty much the same code. Then I create the classifier. Let me start with the same KNN algorithm. So what I do here, I just say I want to create the classifier called k-nearest neighbors. And k-nearest neighbors actually can be a little bit more complicated than I showed you. It can, for example, take 5 closest images and then select the most frequent of them. So for example, if I looked for the closest images and 3 of them were 1s and 2 were 7, 1 and 7 are pretty similar, then I would select 1. It's a little bit more computationally intensive, but probably gives better accuracy. Then I say classifier.learn and provide the data set. I need to convert it to doubles because most machine learning algorithm works with doubles and not ints. So that's why I just do quick conversion to double. And then as soon as I train the classifier, I just say, to get the prediction, I say classifier.decide, and it gives me back the result. So as simple as that. I also need to print the statistics after that, how many percent is correct. Looks like I forgot variables here. Okay, I start this application, and this works exactly like our hand-by-hand model. It trains very quickly and then starts recognizing digits very slowly. It gives accuracy 80%, but because I just take very few examples. Now, if I want to use different algorithm here in a core.NET, because everything is standardized, you can imagine all the trainers would have the similar interface. So what I need to do here, I just change those 2 lines to use another algorithm called SVM. SVM, I will tell you what it is as soon as I start the application, because it takes longer time to train. SVM is called support vector machine. So you can imagine that when I classify digits, they look like points in very many-dimensional space. If it was 2-dimensional space, there would be points on the plane. And if you have 2 clouds of points, to classify them means to draw the line between them. And what SVM does, it draws the line which has the maximum distance to all the clouds. Like it looks like for maximum spread between 2 clouds. There is also a simple model called linear regression. Linear regression would look for the smallest distance between all points to the line. So they are slightly different mathematically. So this SVM, it takes a lot of time to train because it has to compute. I mean, in many-dimensional space, it's not 2-dimensional. It's 784-dimensional, actually. So it's hard to imagine what the plane, separating plane look like. probably if you can imagine, you would not be here. But so 80% accuracy again, which is comparable result. If you compute it on the large data set, so on the large data set, if you do that, it would give you, the SVM would give you 92%, slightly smaller accuracy than with nearest neighbors, but the advantage is that the classification happens almost momentarily. When you provide the digit, you get the answer back immediately. So you can switch between algorithms quite easily, and you can even use neural network in Accord.NET. It looks a little bit weird, but it doesn't use GPU, but you can, if you want to, for some reason, use neural network approach here to train this example. So now let's see how the same thing looks in ML.NET. So ML.NET was announced initially 1 year ago at previous Build conference. You know that Microsoft likes to announce big things at few conferences which happen like twice a year, maybe. One of them is Build. So last year at Build, they announced ML.NET 0.1. They say, we are going to build you wonderful, beautiful ML.NET. Basically, that's what they said last year. This year, they actually showed how it works, because it became ML.NET 1.0. They claim that you can use C# and F# for building custom models. Let's see how it looks. So basically what I need to do here, I would rewrite the same example in ML.NET. I will get rid of this, of everything which we wrote, because ML.NET is a little bit different. I will get rid even of the digit class. So the digit class would look slightly different here. The ML.NET would help me deal with the CSV file. So to do it, I need to tell it where to take the data. So I say that digit class would load the number from the column 0, and then it would load the array called pixel values from the rest 784 columns. So basically, I use these attributes to specify where to take the data from the CSV file. Then, once I did that, I load the data like this. So first I create the thing called ML context. Let me do it a little bit larger. This should look better, right? Okay. So I load the data from, first of all, I create the ML context. ML context is like a variable you use for any interaction with this ML.NET. So you create the context, and then you say, OK, I want to load the data. I say context.data.load from text file. I specify this digit class and the name of the file. Then a few other things, like it has header, a separator is comma. And it would build, it would not load the data, it would build a pipeline step to load the data when needed. Then typically I want to do the data split for train and test data set. Here what I would also do, I would limit the data set for the first 10,000 rows, just for everything to be a little bit faster. And then create the train test split. After that, I would create the pipeline, learning pipeline. So learning pipeline allows you to specify several transformation steps before you actually run the machine learning algorithm. It can be very useful, like if you want, if you take a text, for example, and want to build a model which shows you whether its text is spam or not, like in the email, for example. So typically what you do when you deal with text, you need to convert from words to vectors, to numbers. So this would be the first vectorization step, which would be the first step in the pipeline. And then you would probably do something with numbers, like normalize them, and then you would, at the end, would be machine learning algorithm. So here it's a little bit simpler. Here I just say I want to map the value to key. I want to map the label field into, well, I actually want to map the number field into the thing called label, so that machine learning algorithm can use this as a label, because it can use only the key as a label. And then I say the dot append, so next step of the pipeline would be the learning algorithm. And learning algorithm, you see, if I say, for example, context dot, I have the binary classification, I have anomaly detection, I have clustering, different types of machine learning tasks. So in my case, when I want to recognize digits, it's multi-label, multi-class classification. So I say multi-class classification dot trainers dot, and I have all the list of available algorithms for this task, right? Well, definitely, I mean, toString is not available algorithm, but you can probably tell what it is. And then I would just select one of them. I say label column name is label and feature column name is pixel values. So it would get my model trained. Well, not actually trained. It would create the pipeline, and to train it, I just say pipeline.fit, and as the initial data, I would use train set from split. And then I just check the accuracy. I say I want to apply this model. This is the trained model. I want to apply this model on the test set and calculate the metrics, how accurate the model is. So if I start this, let me just make sure that, yeah, I have the console read key at the end. So this would take some time to run. So ML.NET, you see, it's kind of a little bit more verbose than Accord.NET. Accord.NET is more similar to the way you would write it in Python. Here you have the more complicated concepts. You have this pipeline. Inside the pipeline, there could be different steps. But what's the advantage of this is Accord.NET is pretty simple. It works in memory with the data. Here, this pipeline theoretically can be very large. You can take the pipeline from disk and it would read it as it needs it. Like it would not prefetch everything. Theoretically, you could probably even like do some parallelization and things like that. So ML.NET is intended to solve big problems. In fact, it does, because in ML.NET appeared as the step of development of internal Microsoft product. And inside Microsoft, it was used a lot, like inside Bing Ads, inside Excel, the thing which I showed you, the design, automatic design, it has ML.NET behind it. I mean, I showed you PowerPoint, sorry, but in PowerPoint, Excel, and so on. So a lot of usage of ML.NET inside Microsoft and suitable for big tasks. And there is also another thing called Azure Machine Learning. Azure Machine Learning is very similar to ML.NET, but it's on cloud scale. And the concepts are the same. You have pipeline, you can transform things, and with Azure Machine Learning, you can run really big models in the cloud on clusters and things like that. And that's the reason I did not talk about this here, because like in most of the real cases, you don't need that big scale. And if you start using product like Azure Machine Learning for smaller scale projects, you would get a lot of frustrations. Like I did when I started using it, I said, why do you need to write all that code to do simple things? Like even pipeline processing you can do in Python with pandas in a much easier way. You don't need to do all that complexity. I also did not cover, this model is training, I will show you the result. So I did not cover some nice features available in AutoML, one in ML.NET. One of them is called AutoML. AutoML allows you to automatically try different models and select one with the best accuracy. So imagine you don't want to know anything about machine learning, you just want to train the model. You say, okay, I want to do brute force, like search and try all possible algorithms. This is what AutoML is. And you can call AutoML from command line. There is a command line tool called ML something, ML.NET. You can have even Visual Studio GUI. There is a thing called Model Builder. It's limited to a certain number of problems. You can use it only for like classification and a few more. But it's just a tool which tell me where the data is, and I will find the best model for you. So this is our answer to Python. You don't need to program, you just click and hope that it works. Well, sometimes it does, sometimes it might not. Of course, it's better to know the algorithm itself. What also ML.NET claims, you can use TensorFlow models. Like if some friend who knows Python trained the model for you, you can take the model and use it inside ML.NET. And also there is a thing called Windows ML, which allows you to compute the model very fast if the client machine has GPU. So it also interoperates with this Windows ML. So that's what I covered. You have actually plenty of options to use ML on .NET, but the most interesting thing is of course neural network, right? How neural networks work. I will very briefly tell you about the framework called CNTK, which is a Microsoft framework for training neural networks. And actually neural networks, they are if you start looking at them, they are pretty simple. It's basically multiplication of matrices. So neural network, you have probably seen the picture like this, consists of many neurons, like you have something as input, you have something as output, and some layers in between. And this is mathematically described as multiplying the input by a certain matrix and applying some function like this. So if you start so it's basically what neural network frameworks do. They allow you to do very fast matrix multiplication on GPU of very big matrices. And also those matrices can be not two-dimensional, but more than two-dimensional, and they are called tensors in this case, and that's why TensorFlow. And also they allow you to do training. Training it's like matrix multiplication, but in the opposite direction. I will not go into details here, but let's take this as granted. So on .NET, you have a lot of options to use the neural network models. If somebody trained the model for you, you can use Accord.NET. You can use TensorFlow or Onyx models using ML.NET. You can use TensorFlow through the library called TensorFlow Sharp, and there are many other options. So if somebody trained the model, you are good. You will be able to use it on .NET. So if your task on .NET is to detect existing objects on video, you are good to go. There are examples there, it's an easy task. If you want to train neural network model, that's more difficult, if you want to train it yourself. So for that, as I mentioned, there is Accord.NET, and there is CNTK. CNTK is the Microsoft toolkit for deep learning. It's becoming less and less popular because TensorFlow is becoming more and more popular. So no one, even inside Microsoft, would tell you go and use CNTK. But if you want to use it on .NET, that looks like the only option. So the CNTK works in two modes. First of all, it has the command line interface. So theoretically, you can just tell it, take the data from here, take the neural network architecture from the text file described in a specific language called brain script, and train it. And it would train it, and you are good. This model you can use in your .NET code. Or you can use Python interface for that, or you can use .NET interface for that. So whatever you use, so you can use either this brain script and command line, or you can use Python and you can use .NET. You end up with a neural network model, which you can then load and execute using Windows ML. The main reason you only use CNTK in .NET is that CNTK is written in C++ completely. Unlike TensorFlow. TensorFlow has the core written in C++, but all the training algorithms are written in Python. So you cannot train it. It doesn't mean they are slow, but they are written in Python. They construct the computational graph, and then everything runs in C++. But still, you cannot just say, please train my network. There is no such thing in TensorFlow. And CNTK is completely C++. So the way neural networks typically look, suppose I want to recognize handwritten digits, the same problem as we had before. I take this vector as input. Then to apply the neural network layer, I'll multiply it by weight matrix and end up with a certain vector of 10 elements. Then I want to convert this vector to probabilities. This is done using softmax function. And I end up with a vector saying how probable each digit is. And then I need to somehow compute the error, which is called cross-entropy loss. How different is my result from the desired result? And then from there, I can train my network. So the way it looks in C# is the following. It's very easy. I say, OK, in my case, features is the input digit, is a variable, and label is the number. It is the output of the network. Is also input variable. It's slightly strange. Why is it input, not output? But when I train the network, I provided input and the desired output, and I train it. That's why both of them act as input. So I define those two input variables, and I say the dimension of the first input is 768, and the dimension of the second input is 10. Then the matrix W would be 10 by 768. The dimension of this B shift vector would be bias vector would be 10. And then to compute the network, I multiply W by features plus B. Then I define the errors. I say the cross-entropy loss is like this. I define the learner, and I define trainer. Learner defines the algorithm which I use to train the network. and trainer orchestrates basically the learning process. And then I do the loop, which says take the next number of training samples and please train the network on these samples. So that's how it looks in C# with some omissions. You see, I put ... here, meaning that ... is some ugly text which I have to put there for it to work. And on the right, it's the same code in Python, also with some ... But in Python, only one ... In C# there are more. So on the one hand, if you look at this slide, you can see that the difference is kind of not very big. It looks clean in both cases if you look at this slide. If you look at the actual code, however, it starts looking, well, not too bad still. If it's a simple network, it's not too bad. This is the code to train the network in CNTK. So there is also some code which I put away from here to create the batches of input variables and so on. So it's slightly more complex in C#. Let me show you the previous example, by the way, in ML.NET finished with the accuracy of 84%. So if I run this neural network training, you would see the typical picture how a neural network is being trained. It sits for some time reading data from disk, and then it should start training, improving the accuracy at each step. Yeah, so you see it basically gives you the evaluation accuracy, which was 98%, and then it decreased to some kind of small value of 0.5. This is the typical graph for error, which goes always down with training. And then it tries to apply it on the test data set and gives 89% result. So this was very simple neural network, which is similar to normal linear regression model in machine learning. I would not go into detail what it is, but you can imagine it's a linear combination of input features. There are more complicated neural networks for image recognition for all image-related tasks called convolutional neural networks. The idea of them is the network is basically consists of some filters which run through the image, and they try to detect certain features. Like they try to detect if there was an edge. They try to detect if there was horizontal line, small horizontal line, 5 by 5 pixels. And then so there are a number of those filters. So one filter detects like horizontal lines, other one detects vertical lines, for example, and they detect it, and then they are combined in the next layer of neural network, and then this is repeated several times. I would not go again into detail. I think there was a talk on PyTorch training before, which should probably cover that in more detail. But the idea is that if you do a network like this, you can achieve the highest possible accuracy of like 99%, and 98% it was in my case when I run this. So to do properly image recognition tasks, you would need to do convolutional, and you can do convolutional in CNTK with no problem, but it would be like a little bit more complicated neural network architecture. You would have to write ugly code like this. In Python, it looks a little bit better, but you can do it. So I'm coming to the end of my talk. I mean, this is the same approach you can use for example, training the network to recognize cats and dogs. This was impossible, by the way, like something like 10 years ago. People said we would never be able to recognize cats and dogs with the accuracy of more than like 70%. Now it's easy, but it's a little bit more layers in such network. And also neural networks, they are good for other tasks. There are recurrent networks which allow you to understand text and all sequences, to generate text, and so on. So that's it. I think the main takeaway of my talk is that .NET has a lot of tools for machine learning, and you can use them. Don't be too much afraid of doing so. Also, don't forget that there is F# and there is a thing called Azure Notebooks. They are very convenient for data experimentation. And for C# there is also a thing called Xamarin Workbook, which is similar to notebooks, but they don't run in the cloud, they run on your local machine. And also in the nearest future, like because AI is becoming like massive. Probably every developer should know something about AI. And even though you program in .NET, you can do that as well, but it would be more painful. The main reason it's more painful is not because you have to write more ugly code, but it's mostly because there is much less documentation. For Python, you have a lot of examples. So that's it. I mean, this is the example of how neural networks do object detection nowadays. And this is an example of 2 years ago, algorithm called YOLO. And this is YOLO. You can run YOLO on .NET. Yesterday, I saw a good sample of running YOLO using ML.NET. That's it. If there are any questions, we don't have any time for that, but maybe because they are not throwing us out of the room, maybe we can talk a little bit. No? Okay. Then thank you very much, and have a good day, have a good conference.
Thank you so much.